Late in the 10th century, the Vikings settled in Greenland. They found fertile fields and navigable waters teeming with codfish and seals. Generations had come to call this land their home.
The medieval warm period, when happy Greenland Vikings developed crafts, pursued industry and trade, made fine wine, and even supported a thriving gay community. Okay, I was joking about the wine. Many climate deniers apparently believe that not too long ago, Greenland was green. But to find a Greenland without glaciers and an ice sheet, you have to go back a little further in time. 65 million years ago, crocodile-like reptiles swam and hunted there. The more recent past was less idyllic.
I joined a team of scientists bound for one of the most remote research stations in the world. Their aim to decode the message coming from within the ice. At Camp Neem, the ice is 1.5 miles thick and at bottom hundreds of thousands of years old.
While the North Greenland Eemian Ice Drilling Project, or NEEM, may look like a frontier outpost on the surface, scientists are engaged in very sophisticated research underground. 30 feet below the surface in this huge trench carved from the snow is where this Icecore research begins.
We're getting older and older. With every meter we're melting, we're getting back to the future.
The ice is literally a climate history book that might eventually reach back more than 1 million years.
It's all because the ice is preserved in layers. The further down you drill, the older the snow.
If you took all these pieces of core that have been collected and put them end to end, they're about 2 miles long, and this is a sort of 2-mile time machine.
The most recent Icecore data indicates the Greenland ice sheet is at least 400,000 years old. While Greenland ice cores tell us much about the past, they're not the only cores available. For some 30 years, ice from tropical glaciers has also been examined. Teams from the Byrd Polar Research Center at Ohio State University have packed heavy equipment up some of the highest mountains in the world to preserve a vanishing record. The husband-wife team of Ellen Mosley Thompson and her husband Lonnie Thompson have been among the leading pioneers in this heroic scientific effort. Organizing and leading the transport, often by pack animals, of cutting-edge scientific teams to some of the world's most remote regions. In December of 2010, Ellen Mosley Thompson explained some of their key findings to the American Geophysical Union.
There's no single best ice core. There's no single best place to go to drill an ice core, because where you go to drill an ice core depends upon what the question you are asking is. And when we are interested in global scale phenomena, then we need to have a spatial distribution of ice core records, because ice cores intrinsically carry with them a local to regional signature. So here we can see an example of this. Let's start with the lower panel. This is a composite oxygen isotopic history from these 3 ice cores in the South American Andes. This is today, going back 2,000 years. Up is warm, down is cool. You see a nice signature of the Little Ice Age cool period. You see a modest medieval warm period, or warm anomaly as it's often called, in the South American record. But here is the composite from 4 ice cores from the Tibetan Plateau. And you see no Little Ice Age and no medieval warm anomaly. Now, this isn't surprising in terms of the South American Andes that we see the Little Ice Age in the medieval warm period, because the source for the moisture for these glaciers in the Andes is actually the Atlantic. And it's well known that around particularly the North Atlantic basin, we have a very strong signature of Little Ice Age cool period and the medieval warm period.
So hard evidence from tropical ice cores and other records is showing us empirically that the medieval period that climate deniers like to talk about was indeed regionally warm, but not a global phenomenon like today's.
Now, if we take those records and composite them, we have now what we call the tropical ice core composite. And the one feature that stands out most strongly is the isotopic enrichment of the 20th century. And then when we plot our tropical composite with the Northern Hemisphere reconstruction shown in blue, and it's important to note that that reconstruction is based upon many tree ring series, some coral records, some high-resolution lake sediments, and ice cores. And then in red we have the meteorological observations. And you'd have to conclude that over that 2,000-year history, the tropical records composited don't look significantly different from the Northern Hemisphere reconstruction. But both again carry the signature of the 20th century warming, and particularly the stronger warming in the latter 50 years.
Climate deniers love to tell you that the science of global warming depends on abstractions and computer models. But the evidence for man-caused warming, in fact, has been painstakingly built by some of the hardest of the hard sciences, the real boots-on-the-ground grunt work of courageous and dedicated professionals, the spiritual heirs of bold Viking explorers of the past. The tiny colonies that survived in Greenland during a brief regional mile period must indeed have been tough and resourceful people, but not the thriving high culture of climate denier imagination, which owes far more to Hollywood than to history. To stay informed on what the real science and real data tell us about our planet's history, keep coming back to Climate Denial Crock of the Week.
Verður ertu víst að fá vísu gamli hjartur, aldrei hefur fallið frá frækilegri gartur. Hani, krummi, hundur, svín, hestur, mús, tittlingur, galar, krungar, gettir, hrín, meggjar, tístir, syngur.